Okay. Find critical points. Just like yesterday, how do we find the critical points? The derivative. Y prime is, what is y prime? Carol, let me know.
3x squared minus 2.
Good. And we take the derivative and we do what, Leo? Perfect. And guys, what's your next step? Solve for x. You're right. Solve for x. Okay. Can you please help me solve for x, Ryan? What do you do? Good. Add 2 to this side. Divide both sides by 3. So x squared equals 2 divided by 3. Last step. Good. Square root both sides. Dear self, when I take a square root, how many answers should you come up with? Plus and minus. Okay. This is really technically rad 2 over rad 3. So if you choose to rationalize, it could be seen as rad 6 divided by 3. So those are the two x values. Someone use a calculator for me, punch in what's rad 6 divided by 3? Approximately what? Plus or minus what? Well, just later so we can do, when we do our number line, we know where to plot these. Two decimal places if you have it. 0.82. So plus or minus 0.82. The reason I want to know decimal is later when we do the number line to see what's maximum, then we want to know where it is. Okay, we got the critical point. There are 2 of them. Now what? Do we have endpoints? No. Okay. So on step 2, normally you would plug in the critical and the endpoints. Plug in critical and endpoints, but in this case we don't have any. Okay. Into f of x. Well, why would you do that? Why would you plug in critical or endpoints into the original equation? To find the y value, because it's min and max are the y values. Okay, x is just the location. All right, let's plug it in. So let's do the positive first. Rad 6 over 3 is, the original was x to the third. So rad 6 to the third divided by 3 to the third minus 2 times rad 6 divided by 3, and that was plus 4 at the end. So rad 6 to the third, that's really 6 rad 6, yes or no? Divided by 3 to the third is what? 27. This is just going to be minus 2 rad 6 over 3. This is going to be 4 over 1. Common denominator tell me that they should all be what? 27. So 6 rad 6. This is all over 27. That means I need to multiply this denominator by 9. Yes, no, maybe? And multiply this by 27, multiply this by 27, multiply this by 9. So 2 times 9 is going to give me 18 rad 6. 4 times 27 is going to give me 108. Okay, let's combine. 6 minus 18 rad 6 rad 6 minus 18 rad 6 is negative 12 rad 6 plus 108 all over 27. 108, that is reducible by 3. Okay, so let's factor out a 3 in the front. Where, what? What are we talking about? Yeah, the 27's not going to help me. Yeah, that's okay. I'm just going to factor out a 3. Is that okay? That would be negative 4 rad 6. 108 divided by 3 is 36. Yeah, no, I'm just trying to simplify the bottom as well. Does that make sense? Okay. Now I can cancel the 3. Yes or no? Yeah, so final answer without a calculator is negative 4 rad 6 plus 36 all over 9. Okay, so that's your y value. I'll box that up. Now, some of you already have a calculator out. What is that in decimal?
2.91.
Perfect. Thank you so much. Okay. Then we have to do the other critical point to get our output. So similarly, negative rad 6 all over 3 is going to be negative rad 6 all over 3 raised to the third power minus 2 times negative rad 6 all over 3 plus 4. Go ahead and work out the basic math and then give me the final exact and decimal answers, okay? You can talk to your shoulder partners. Bless you. That's why I gave you the entire page, right? For this one example, there's lots and lots of basic math. Bless you. Bless you. Is this your exact answer, guys? Okay. Go ahead and give me in decimal form.
5.1.
5.1, thank you. 5. Well, since Brady gave it to me in 2 decimal places, so give it to me so that way we.
0.09.
09, perfect, okay. All right, so guys, we have 2. What are you going to do? Now, how do you know which one's min and which one's max? Which one's min and which one's max?
Is that when you go back into the equation and then you plug in like an infinity, then a negative infinity, or a number to that extent, and you see which ones, if it's lower, a number to judge the end of the equation?
Yeah, some of you can see it right away. Some of you, if you don't care, it says, okay, you know, I'm going to make a number line and see what's happening, right? You have 2 critical points. One is a negative and one's a positive. So the first one was a x value. The first x value was negative rad 6 over 3. Negative rad 6 over 3, which Brady gave me an equivalency of negative 0.82. Negative 0.82. And this is positive rad 6 over 3, and that was a positive rad 0.82. Well, obviously, is it technically one is min, one is max, or they're both max, or they're both min? How do we figure it out? Okay, we already have the y value. Can you guys agree? Okay, the y value at negative rad 6 over 3 is 5.9, 5.09. I'm sorry. Yes or no? So it's kind of higher up here. This is 5.09. The y value at rad 6 over 3 is 2.91. So it's a little bit lower. True or false? But how do I know if they're both min or max? Or one's max, one's min? Uh-huh.
Could you use that as like a base of your distance of the positive cubic function?
Thank you. What about it? Continue. How does a positive cubic function go? As x approaches positive infinity, what's happening to y? Goes up. As x approaches negative infinity, what's happening to y? Negative goes down. Okay. So perfect. Well said. So what's happening? A carrot kind of piggyback on that. As x is approaching positive infinity, would you agree that goes like that?
Yeah.
And then this goes like that.
Yeah.
Okay. So obviously somewhere in between it's like that, right? Or whoa, my line went disappear. Okay. So now, if we know exactly what it looks like, what is min and what's max? Local. Can you agree that's not an absolute? Yeah. Local, let's start with local max. Local max is what? 5.09 at x equals to negative 0.82. So that's local max. Is the other one local max as well? No, the other one is local min. Is 2.91 at x equals positive 0.82. Perfect. Okay. Some of you already know the end behavior, and obviously if you know the end behavior, it's kind of easy to figure it out, but it's always a good idea to kind of make a number line for it. Okay, why don't you get a head start on example B, 4B. I don't expect you to finish, but get a head start. Let's see how far you and your partner can finish in a minute. Again, I'm not expecting you to finish at all, just I want to see if you get a head start on that.
Is that how long is this take on like these types of questions?
Should be on the exam, yeah. But right now we're taking notes, so it will definitely take a lot longer. How far did you get? That's okay. What did you do first? What did you guys do first?
Take the derivative.
Take the derivative and do what?
Set it to 0.
Good. Y prime is 3x squared minus what? 6x plus 3. And take it, say it goes 0. Is it factorable? Yeah, okay, let's factor out 3. If I take out 3, I have an x squared minus 2x plus 1 equals 0. Bless you. Bless you. Does that seem about right? Yeah, so there's one critical point, right, y'all? Yeah, do we have endpoints? No, what do I do with the endpoints and critical points? Since, well, I don't have any endpoints. What do we do with the critical points? Plug it back into f of x. So f of 1 is 1 to the third minus 3 times 1 square plus 3 times 1 minus 2. What is f at 1? Negative 1. Okay. How do I know that's min? That's max. What do you do? Now what? Should I make a number line just for visual aid? Sure. Okay. What kind of function do we have? Cubic, quartic, quadratic, linear. Okay. At x equals to 1, here's x equals to 1. Your output is negative 1, so it's below my x-axis. Yes or no? Yeah? Okay, tell me. What do you do now? 0? Is it? Okay, let's do endpoint for it, and then we'll pick a new value. As x approaches positive infinity, what's happening to the output? Positive. So would you agree, if I just sketch it out, this goes like that? Yes or no? If I sketch out as x approaches negative infinity, what's happening to the output? Negative. Yes or no? Okay, so here you go. So Sierra said, oh well, should I pick points on the right and left of that? Like 2 and 0.
Yes.
When x is 0, which is to the left, what's happening? It's negative. When x is 2, is it higher than negative 1 or lower than negative 1? It should be higher. Well, what can you conclude? There isn't any critical points. Because the definition of maximum is, remember, maximum means you have values around it that are lessened for it to be max. Minimum means you have value around that need to be higher, right? But you have one's lower, one's higher, so guess what? There isn't any. This is called an inflection point for a cubic function. You guys remember this? Yep. Okay, so if I were to sketch that out, okay, so this one, no extreme values. Example 5. Can you, Yui, help me read the instruction to example 5?
Find the derivative at each critical point and determine the local extreme value.
Whoa, you have to use a derivative. Okay. And what kind of function are these? Piecewise. All right, y'all. Anytime that you are asked to find the extreme values, you are still doing the same exact steps. What's your first step? Find the critical point. Okay, so find f prime of x. How do we do that? The derivative of the first piece is -1 when x is less than 0. What's the derivative of your second piece? -2x plus 2 when x is greater than or equal to. Oh, actually, does the derivative exist at 0? No, so it's just greater than 0. The derivative does not exist at 0, so we can't have an inclusive. Let's plug in 0 quickly for me, because I think some of us are still puzzled. Guys, what's f of 0 for the first piece? F of 0 in the first piece, what is it? 3. F of 0 in the second piece? 3. The algebra value exists. Does that make sense? Okay, let's talk about this really quickly. Let's bring us back to derivatives. Algebra value is continuous. Yes or no? Yes. It's continuous. But what's happening to the slope coming towards 0 from the left? It's -1. The slope is flat, it's constant. The slope coming towards 0 from the right is not flat, or in this case, not -1. Does that make sense? So the two slopes are, as you can see, the slope is -1, the slope over here is varies. Right? But too close. Okay. So that's why it doesn't exist at 0. Now what? So let's I can't set equals to 0, okay? But the critical point doesn't just be 0. Where do you think that, based on the definition of critical point, what do you guys remember? Besides it, the derivative equals to 0, what else can it be? Critical point here. 0 is what we have been using. But besides the critical points being 0, what else? Where it does not exist. And we just talked about why it doesn't exist, right? So for this example, where is it that it does not exist? 0. Okay. Okay, so let me spell that out. Left-hand derivative at x equals 0 is what? I don't know what you said when you yawn. Left-hand derivative at x equals 0 is? -1. Oh, left, I spelled left wrong. Right-hand derivative at x equals to -1 is what? I mean, x equals to 0 is what? Is 2. Yes or no? So, does the derivative exist at x equals to 0? No. Okay. Derivative, therefore, derivative does not dne at x equal to 0. So that means it is a critical point. Okay. Are there any other critical points? Are there any other x locations where the derivative is 0? Where? How do you know? Yeah. So this is our derivative function, right? I have to find all of the values. Would you agree? When the derivative is 0 and when it doesn't exist. So we start with when it doesn't exist. Well, I can't do much with this. That's a constant. But this one, when I take this and it's set equal to 0, x has to be 1. Okay. So that's our next piece. Negative 2x plus 2 equals to 0. Negative 2x equals negative 2. X equal to 1 is the other critical point. So how many critical points do we have? 2. What do we do with critical points and endpoints? Plug it in. Do we have endpoints? No. Okay. So plug them in. Here we go. F of 0. Which piece are we plugging 0 in? First or second? Second. What is it? 3. 3. Well, x is 0. Everything's 0 except 3. True or false? And then f of 1, which piece? First or second? It's second still. So 3 plus 2 is 5 minus 1. So what's that? 4. Can you see right away whether they're both they're both max, both min, one max, one min, or neither? What do? Number line? Yeah, visual aid. I'm a visual learner to begin with anyway. So I have 3 right here, right? I have 4 over here on my number line. I meant those are the outputs. Woo, thank you. 0 and 1. They're both above my x-axis. Would you guys agree? 3 is right here. 4 is a bit higher. So now what? What do you do? What do you do? Plug it in. Let's do like ending it here.
Yeah.
When x is like all over here to negative, which piece are you gonna plug in? First piece. And is that a line or parabola or cubic or what was that one? It's a, let me pinch it back in because can't see. The first piece is negative x plus 3. Yes or no?
Yes.
That means when x is approaching negative infinity, like negative 100, negative 1,000, it's always positive. Because negative x times a negative 1,000 plus 3 is always positive. Okay. So this is always this way. True or false?
True.
How about end behavior on the right side? X approaches positive 1,000, positive 1,000,000. What's happening? Always what? Negative. Okay. So I have to connect this from here to here. So can we conclude? What can you conclude? L, the first dot, is that L min or L max? L min is what? Is 3 at x equals 0. Second is L max is what? 4 at x equal to 1. Yeah, 0 was already used for L min. Okay, yes?
What was your thought process when finding the second critical point?
Remember the definition, good question. The definition of critical point is when the derivative is 0 and when it does not exist, right? Because it is a piecewise, Jordan, okay. Because this is a piecewise, okay. When we took the derivative, the slope coming, the left-hand derivative is negative 1. The right-hand derivative is 2. So, because it's not the same, therefore the derivative does not exist at 0. is not the same. Right? So that's why the first critical point is that. But the definition of critical point is also when it equals to 0. So take this whole thing, set it equals to 0. The first piece is never going to be possible, right? But the second piece, I could have a value, sometimes more than that. Okay. How about let's give ourselves 2 minutes for you guys to head to our RMV to see how far you can go. 2 or 3? Let's do this 3. 5 triplets. These sound pretty good, okay? Maybe they talk to each other party, right? Step number 1. Dylan, what did you do first, Dylan? Okay, what is the first piece derivative? What did you get, Dylan? Good. When x is less than 1, right? Second piece, what's the derivative? Okay. Plus 6, so x is greater than 1. Is it, does the derivative exist at 1, y'all? No? Yes or no? No. Okay. Derivative. By the way, what was the left-hand derivative at 1? Left-hand derivative at x equals to 1 is, you said negative 4?
Yeah.
Right-hand derivative?
Is 4.
I can't spell right or left today. Right-hand derivative at x equals to 1 is 4, you said?
4.
It's 4, thank you. So first critical point is, okay, so first critical point. It's x equals to 1. All right, I got 1. Are there others? Yeah, how many more? 2 more. Oh my, okay. I'm going to take the first piece and say it equals to 0. Is that okay? And then the second piece and say it goes to 0. So the first piece, what did you guys end up with? -1. So there's 1 more. Second piece, x is 3. So you got 3 critical points all together. Ready? Do you know which one's which? Min, max? All of them min? All of them max? None of them? What's your next step? Plug in, okay. All right, I'm gonna put my x's in order. X is, oh, let's plug it in. Let's plug in f of -1 in order, f of 1 in order, and f of 3. When you plug in f of -1, what did you come up with? -11. Someone confirm? You got 5? Let me, okay, so when x is -1, first piece or second piece? First piece, so -1 square, yay or nay? -2 times -1 plus 4. It is what? 5? Okay. When f is 1, f of 1, what is it? 1. Someone confirm that for me. F of 3? 5. Okay. Whoa, 2 that are 5. Let's see what's going on here. Okay, we have -1 location, 1 location, and 3 location. Okay, the outputs are, first one is at 5, this one's slightly lower, and this one's up here. Yes or no? Now what do you do? As x approaches positive infinity, what's the end behavior? Positive? Someone confirm that for me?
We know negative.
Negative? Someone confirm that for me? Negative, so it's like this? As x approaches negative infinity. There's negative as well? Negative as well. Oh, whoa. So would you agree it's going to be like that? All right, what did you write as your final answer? It's an absolute. Absolute max is what? 5. At how many locations? -1 and 3. Absolute. No, actually, there's no absolute min. That's not an absolute min. It's a local min. Is 1 at x equal to 1. Beautiful. Your book, by the way, doesn't do the number line. Your book does a chart. You feel free to do whatever you feel comfortable with.
Do you have to write for the A max if it's also an L max too?
A max is L max as well. Correct. Correct. Okay. This one, I believe, is just asking for local. So you can write L max. It's totally acceptable. Last example today. And we're done for 4-1. Yay! There are 12 sections altogether. 12. At the mid section, which is 6. The end of 6. Okay. Can you help us read example 6 instruction? Por favor, Lisa. What? Same instruction?
Step 1.
Step 1. You tell me what to do. Critical point. So y prime? How do you do that, y'all? If I were you, I would rewrite this to a negative exponent. Why? Because it's a lot easier than quotient rule, right? All right, y prime. Tell me what to write. -1 times x squared minus 1 to what power? -2 times the derivative of the inner. What's your inner? X squared minus 1. I'm writing a step. If you can go straight, go for it. Okay. -1 times x squared minus 1 to the -2 power. That derivative is going to be 2x. Yay, nay, maybe so? Yay. then I'm going to rewrite it. Y prime equals, on the numerator, we'll get a negative 2x. On the denominator, we'll get x squared minus 1 to positive what power? 2. Take it and set it equals to 0. First, identify where the derivative does not exist. Do we have a vertical asymptote? At 1. Just 1? Because when you take a square root, what happens? You have 2 of them, okay? So the denominator, y'all, this denominator, make sure you're mindful of it. X can never ever be positive and negative. 1. That's the critical point. Yes or no? Because that's where the discontinuity is, okay? How do we solve for x from there? Can I cross multiply? If I cross multiply, my whole denominator is gone. That means you only have negative 2x equals to 0. That means x is 0. How many critical points do you have all together? 3. Let's plug in our values. F of negative 1, f of 0, and f of 1. Go ahead and plug it in. Give me the output. And then we'll do our number line to see where they are. Does it exist, all of them? That's another question. Is f at negative 1 possible? No. F of 0?
C.
What is it? Negative uno? Is f of 1 possible? No. Okay. So, right away, can you tell right away, you only have 1 point, by the way. Can you tell right away if that's a min, that max doesn't exist? What do you do? Okay, let's have a visual aid. Why not? I'm a visual learner anyway. Okay. You have 3 critical points, negative 1, 0, and 1. What's happening at positive and negative 1 to the original equation? They are, okay? They're totally asymptotes. Like that. And we know at x equals to 0, the output was negative 1, so it's right there. True or false? True. Now we have to decide. In algebra 2, what kind of function is this? Yeah, it's a rational function, right? So the end behavior said, okay, as x approaches positive 1,000, it's always what? Positive. And then over here, as x approaches negative 1,000, it's also always positive. So right now, the curve, if I were to sketch it out, it looks like this. Remember this curve? Because it's always positive. Now the middle part is the tricky part. I don't have any other critical points. I've already used up my end behavior. What do you do to decide if that's a min or max? There's 1 dot. Is it a max?
Yeah.
How do you know?
It's opposite.
If I think about it,
Vertical line test.
what if I plug in a negative half?
Horizontal.
Okay?
I don't know.
Guys, this is what you do. When you can't decide, pick points near it to see if it's higher or lower. What if I pick in negative half? What's negative half square?
1/4.
A quarter, take away 1. Negative 3/4. 1 divided by negative 3/4.
Negative 1/3.
Lower or higher than that? Lower. How about if I pick positive half? It should be the same, right?
Yeah.
So as you can see, it's lower than my original dot. So it looks like it curves down like this. So we can conclude that that is a local max. Local max is negative 1 at x equals to 0. And again, I'm writing a lot more than what your book does. And I'm not using the same method as your book does. But if you like the way that the book does it, then you can use that. Last example. Similarly, do y derivative. y prime. Should we rewrite it as negative exponents? Yeah, it's better than quotient rule. Okay, so it's going to be 1 minus x squared, all of it raised to what power? Negative what? 1/3. All right, y prime, here we go. Chain rule says, drop down your power, so it's negative 1/3 times the inner, which is 1 minus x squared to the power of what? Negative 4/3 times the derivative of the inner. And again, I'm just writing all the steps out. Oops. So if you can go straight, go for it. So the derivative of the inner is going to give me what? Negative 2x. Negative 4/3 times negative 2x. I'm going to rewrite it as fractions. Here we go. On the top is now a positive 2x. Yay or nay? On the bottom, what did you get? Square root of, not square root, cube root of 1 minus x squared, all of it raised to the 4th power. So let's identify what x can't be. What is it x can't be? And remember, I don't care to simplify because I'm just looking for critical points. Okay. Set equals to 0. What is it that x can never ever be in the bottom? Okay, x can never ever be positive or negative 1. Beautiful. Solve for x, meaning that I'm going to cross multiply. When I cross multiply, the denominator is completely gone. So now you just have 2x equals to 0. That means x is going to be at 0. Similar to the previous one, isn't it? Okay, let's keep on going. Now what? Just like previous one, what do? Plug it in. There we go. F of negative 1 is, f of 0 is, f of 1 is. What's happening at f of negative 1? Asymptotes, right? Does not exist. So x, what's happening at f equals to 0? What do we get? 1. What's happening at f equals to 1? Asymptotes again, okay? Because it doesn't exist. So sketch this out just like earlier. I have 3 values, negative 1, 0, and 1. At these 2 locations, the original was also asymptotes. At x equals to 0, your output is now positive 1. True or false? The end behavior says, as x approaches negative infinity, what's happening? It's always what? As x approaches negative infinity, what's happening? It's always negative. So it's somewhere down here. How about as x approaches positive infinity? It's always negatives. Oh, well, that's not going to help you. So is this a middle point? What happens? What do we do there? Is it a parabola opening down? Is it a parabola opening up? Is it a cubic? How do you decide? Should we take a quarter again? I mean, a half, a quarter, whatever. What happens when you take positive half or negative half? So I'm going to plug in negative half. So let's see. Here we go. This is my original. It's always what? Positive, right? Higher or lower than my dot? Because that's what I need to decide. Higher or lower than 1? 1 divided by a fraction is always going to be higher. Would you guys agree with that? Okay. So it's high. I don't care how high. I just know it's higher. Okay. So would you agree that this is higher, like that? Okay. Remember, the whole thing is, do you know if it's higher or lower than your critical point? So is that a local min, local max? Local min is 1 at x equals to 0. That concludes our day.